How does a chemical plant automatically maintain temperature, pressure, flow or level at the desired value? One of the most important technologies behind this automatic control is PID controller. Let's understand what P, I and D actually do. PID stands for proportional, integral and derivative. A PID controller compares the desired value called the set point with the actual process value. It then calculates a controller output to reduce the difference between them. Before understanding P, I and D, we need to understand error. For example, if the required reactor temperature is 80 degrees Celsius, but the actual temperature is 75 degrees, there is a difference between the desired and actual value. The controller uses this information to determine its output. Proportional action response to the present error. If the error is large, the proportional response is larger. As the error becomes smaller, the proportional response also becomes smaller. A simple way to remember it is P responds to the error that exists now. Integral action considers the accumulated error over time. Even when the error is small, if it continues for a period of time, the integral action keeps responding to the accumulated error. This helps eliminate persistent steady state error. Derivative action responds to the rate at which the error is changing. It looks at the trend rather than only the size of the error. If the process value is changing rapidly, derivative action can provide a corrective response that helps the controller anticipate the direction of the change. PID controller combines all three actions: proportional response to the present error, integral response to the accumulated error, derivative response to the rate of change. Together, these actions can provide effective automatic control when the controller is properly configured for the process. Let's take a simple reactor temperature example. Suppose the required temperature is 80 degrees Celsius. The temperature transmitter measures the actual reactor temperature and sends the process value to the PID controller. The controller compares it with the set point and adjusts its output to the steam control valve. The value changes steam flow to help bring the reactor temperature towards the desired value. Easiest way to remember PID is P is for present error, I is for accumulated error, D is for rate of change. A PID controller continuously uses this action to calculate the corrective output for this process. Follow Industrial Operation Academy for more practical knowledge on chemical plant operations, instrumentation, process control, maintenance and industrial safety.